Good morning to all. To start with, may we all rise and be one in mind and spirit as we praise and thank our God Almighty for all His graces and blessings through prayer.
प्रभो गणपति परिपूर्ण வாழ்வருள்வாயே प्रभो गणपति परिपूर्ण வாழ்வருள்வாயே प्रभो गणपति 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 சார்ந்து வணங்கி துதி பாடி ஆடி உந்தன் சந்நிதி சரணடைந்தோமே சார்ந்து வணங்கி துதி பாடி ஆடி உந்தன் சந்நிதி சரணடைந்தோமே சாந்த சித்த சௌபாக்கியம் யாவையும் தந்தருள் சத்குரு நீயே சாந்த சித்த சௌபாக்கியம் யாவையும் தந்தருள் சத்குரு நீயே பிரபோ கணபதி பரிபூரண வாழ்வருள்வாயே பிரபோ கணபதி கணபதி கணபதி.
Inauguration is a welcomed gift to encourage others to achieve greatness. To formally inaugurate the seminar, I welcome our beloved principal, Dr. C. Siranganayagi Madam, JKK Nadaraja College of Arts and Science.
Good morning to one and all present here. It gives me immense pleasure to be with you this morning at the opening session on International Seminar on Energy Harvesting and Sensors. On behalf of JKK Nadaraja College of Arts and Science, I extend a hearty welcome to all the speakers and participants in this seminar. I am grateful to our Secretary Madam, Managing Director Sir, Dean Madam for permitting us to conduct this seminar. I appreciate the faculty members of Department of Chemistry for organizing this seminar. Chemistry plays a key role in conquering diseases, solving energy problems, addressing environmental problems, providing the discoveries that lead to new industries and developing new materials and technologies for national defense and homeland security. However, the field is currently facing a crucial time of change and is struggling to position itself to meet the needs of future as it expands beyond its traditional core towards areas related to biology, material science, and nanotechnology. Hope this seminar will motivate the participants towards the innovative research on energy harvesting and sensors. Thank you.
Thank you, Madam. To kickstart this first session and to welcome our resource person and to welcome the gathering, I invite Mrs. S. Maladi Madam, Associate Professor and Head, Department of Chemistry, JKK Nadaraja College of Arts and Science.
Good morning, everyone. I feel honored to welcome our chief guest, Dr. P. Saravanakumar, all faculty members, research scholars, and students for this webinar on vibration energy harvesting for cell power application. I thank all for being with us today. I am very much happy to introduce the resource person of the session, Dr. P. Saravanakumar, Junior Assistant, Laboratory for Advanced Research in Polymer Materials, Central Institute of Petrochemicals Engineering and Technology, Patia, Bhubaneswar, Odisha. Dr. P. Saravanakumar did his undergraduate and postgraduate in physics at Bardea University, Coimbatore. He has completed research work in mechatronics engineering at Seju National University. He started his career as a lecturer at K.S. Rangaswamy College, Tiruchengodu in 2007 to 10. Then he worked as a researcher at Chonbuk National University, South Korea in 2010 to 11. From 2015 to 18, he worked as a postdoctoral researcher at University Francois Rabelais, France, Chonbuk National University, South Korea, and then South China National Normal University, China. His area of specialization are synthesis and characterization of nanomaterials, energy harvesting and storage applications, microfabrication techniques for lower electronic applications. Dr. Saravakumar has published more than 60 research articles in internationally reputed journals. His articles were cited by 2,950 research groups and H index reached to 30. Dr. Sarvar Kumar is an author of the following book chapters: three-dimensional porous binary metal oxide networks for high-performance supercapacitor electrodes, fabrication and characterization of supercapacitors through a cell-powered system, piezoelectrochemical devices, fabrication mechanism, multifunctional piezoelectronic oxide nanostructures, fabrication methods, devices, and applications, metal oxide series, and a trend towards flexible supercapacitor, understanding the electrodes and the electrolytes. Dr. Sarvana Kumar guided 7 PG students and currently he is guiding 1 PhD student. One of his students received international internship at the University Technology Malaysia. He owns 2 patents, one for fabrication of new zinc oxide nano-generator device structure for eco-friendly energy harvesting and another for self-charging supercapacitor device and fabricated method. He is about to get 2 more patents. He has received 3 international Best Poster Awards and one Best Oral Presentation Awards. He has organized 12th chapter of International Conference on Advanced Polymeric Materials by virtual conference from March 9 to 13, 2021. He was listed by Stanford University Researcher as a top 2% scientist in the world. I am sure that we will all feel enriched with knowledge on vibrational energy harvesting for self-power application after completion of this webinar. With this brief introduction, now we welcome our chief guest, Dr. B. Saravana Kumar, and hand over the session to him. Thank you.
Thank you, ma'am. Sir, now the session is over to you.
Thank you so much. Screen is visible.
Yes, sir. Visible.
Yes, sir.
Okay, my voice is audible.
Yes, audible, sir.
Okay. First of all, I would like to thank JKK College for giving this opportunity to share my research experience with young minds, many students. First of all, I would like to thank Principal Madam for nice introduction and as well as for HOD Madam for nice introduction. So today I'm going to discuss about my work and few things about recent trends on energy harvesting techniques, which is nothing but mostly I'm going to focus only on vibrational energy harvesting techniques for self-powered systems. So myself, Dr. B. Saravana Kumar, working as a junior scientist in SIPET. So before going to these topics, I'm going to elaborate few things about my institutes. So where I'm located and what are the work we are carrying out in past more than 15 years. Our institute is nothing but the SIPET, shortly called as a SIPET. It is a full form is Central Institute for Petrochemicals Engineering and Technology. So formally it is called as a Central Institute of Plastic Engineering and Technology. Actually, it is not a one center. So we are located all over the India. So we have nearly 46 centers in different parts of countries. Our main aim, so we are not only focuses on the R&D or in the aspect of teaching. So we have a different level of expertise. We can call as a expertise. Actually, our head office situated in Chennai. So our first center is initiated at Chennai. The basic motto of our institute is to skill development of people in the field of plastic industries. So this institute had started 15 years back when plastic entered into Indian market. So people are not aware of plastics and how to proceed.
Sir, excuse me. Sorry
Hello.
for the interruption.
Okay.
Can you make a slideshow mode?
Is it
Full
okay?
screen, full screen.
Now full screen only. Now full screen only.
Sorry, sir, not yet.
Okay. One more time, I will stop and share again.
Okay, sir, please.
Able to see my screen?
Yes, sir. Visible.
Visible. No problem. So can I continue?
Yes, sir.
Okay. Yes, I told CPET is initially meant to give skill development for people who really need for industries. So we have a lot of facilities which are more adequate with industries. So we started our journey with skill development. Then slowly we are extend our origin in different aspects. Now we are providing the graduate, undergraduate courses mostly related to the plastic and petrochemical industries. And we are providing the PhD service, PhD in the field of polymer and its allied field. We are not only restricted with teaching and skill development. So our half of the work is to testing or evaluation the industrial products as per the NABL accredited laboratories. So we have nearly 46 centers all over the India. So we are concentrated in different aspects. What I told before, we are starting from skill development. So which is all coming under the head of CSTS. So Center for Skill and Technical Development Department. And other than this, we are providing the higher educations in the level of UG and PG. So which is coming under the name of IPT, Institute of Petrochemical Technology. Other than this, so we have R&D wings, 3 R&D wings situated in different part of India. One is at Chennai. The Chennai center mostly focuses on the recent advancements in additive manufacturing. So they have a well-equipped facilities for 3D printing, both FDM, SLS, SLD, so many things. Another one center which is located presently in Bhubaneswar, where I am working now. So here we are working and developing new kinds of polymer materials for industrial requirements. Like we are mostly working on the different polymer composites for automobile industry, healthcare sectors, and as well as for biodegradable packaging applications and so many things. Another one R&D center which is situated at Bangalore, which is the hybrid of these two objectives. They are focusing on the developing new materials and as well as they are working on the recent and hi-fi 3D printing and other techniques. So based on this introduction, so I am going to enter into our today's topics. So today's my presentation cover. So first we want to know what is the energy harvesting. Why we are calling energy harvesting? So you need some basics about energy harvesting and other things. And next one, how this is working. Basically, what is the basic mechanism behind this to generate the electricity? So here I am going to discuss fully about the how we are going to get electricity from the materials. Okay, and what are the figure of merits for this type of devices and applications? I'm going to little bit about my own research work. Everyone know about energy. So now most of the people are pronouncing the word energy because now you are taking into fuel cost. It is more than 110 rupees. So now people are thinking the alternative for fossil fuels, nothing but petrol and other things. Why now the requirement of petrol or other energy is escalating? Because you are taking into 50 years back and now most of the people are transporting with their own vehicles. So the number of transportation mode is increases largely. So you can say if 100 people before using vehicle means now 1,000 people, 10,000 people, more than that. So the energy needs for transportation is very, very essential. Other than that, now lot of construction and other things. So we are using many electricity for only for the energize the our buildings. And of course, so a lot of industries are developed compared to 15 years back. Now, apart from this, we are not only using this three part most of the energy. We are using many other places. You see, if you are taking each and every people, now everyone have a small electronic gadgets. It's starting maybe from computer, small smart watches, so many other electronic gadgets. It's starting from small smartwatch to mobile, so many advanced electronic gadgets. So everything it's need to be operated sustainably means it's need energy to operate this type of electronic gadgets as well as the automobile and building so on. So where we will get this energy for this type of electronic devices? Basically, the most of the energy until now we are getting from the fossil fuels. Like if you are taking all transportations, we are fueling with petrol, diesel, and now we are little bit turned towards the EVA. So that is the second part. But mostly we are using our energy needs from the fossil fuels. For home electricity, how we are getting? We are getting from coal mine or we are getting from nuclear power plants, so on. Even though we have a lot of nuclear power plant, but our most of the energy needs are satisfied by the coal mining. So we are burning the coal and getting the energy from these coals. So the most of the energies we are getting.
Sir, excuse me.
Yes.
Sir, are you moving the slides or still stick with second slide?
No, I moved it.
Actually, it is not moving. That's why. Yeah, now it is moved.
Okay, some issue. Okay, next time I will. Okay.
Please, sir. Okay, thank you.
Okay. So the most of the energies we are getting from fossil fuels. So what is the problem for getting the energy from fossil fuels? Because one thing is, it is getting from our nature earth. So the availability of these type of fossil fuel are restricted. So where how much you need, you cannot everything getting from our earth. So it have a limitation. It have availability is very restricted one. If you are burning and burning and burning, you will get energy, but we will not get these resources again and again because it will take very long period to convert from normal your carbon into this type of fossil fuels. And another thing, you are using these things. What will happen? You are burning. So your burning means you are releasing lot of enormous greenhouse gases like carbon dioxide, carbon monoxide, and so on. So what is the problem for releasing this? If you are utilizing more and more amount of these fossil fuels, what is happening means, so we are now facing the global warming. The heat of our environment is increases. So we are seeing a lot of abnormality in our environment. So this is majorly from this the burning of these fossil fuels. If you are taking global energy demand, so in Indian consumption, if you are compared to all other world, it is less. Even though India is a highly populated country, the energy needs in the future is it's more and more than compared to other countries. So which is around 1540 MOTN, which is less. But even though we are developing country, our population is more, so our energy needs may be beyond this limits. So we need more fossil fuels to burn to get our energy needs. I rightly said before, so if burning of this type of fossil fuel, what is going to happen? Because of burning of this type of fossil fuels, it releases lot of our greenhouse gases. So what is going to happen when releasing of greenhouse gases? See, so now you know, if you are asking your elder people like your grandfather or grandmother, they faces lot of water. They lived with good environment than us. They have a good climatic condition. They are getting proper rain. They are not facing so many environmental disorder. Like, see, now we are facing lot of like cyclones. So this is because of the intolerance of the temperature difference over the earth. So because of these temperature differences, what will happen? It will change us the ecosystem. See, for example, you are taking any human, or not only human, if you are taking any animals or any other things, the ecosystem is properly, then only its living environment will be ideal for them to grow, and it will develop their next generations. If it is not there, what will happen? This whole system will be affected, because we know the earth is a good biodiversity, and other things, it have a good balance between the different parts. Okay, the increasing of this greenhouse gases, what will happen? It trap them heat energy. So because of this trapping of heat energy, it increases our heating, our environmental heat. So if it is heating is more, means what will happen? The more number of water evaporation. So this will alter the our environment. So because of this imbalance, it increases the water level in ocean, and as well as it melts the ices in the polar sides of our earth. So which will change our diversity. So because of change in water level, and as well as the increases the humidity and other factors, it will change our cycle. Like we have a 4 season. Okay, because of this alteration in the biodiversity, it will change. Rainy season we will not get rain. Summer season we will get more sun out. So because of this reason, our whole biodiversity will be changed. And another thing, some place you are getting more rain, some place you will not get rain. So because of this, your whole nature will be spoiled out. So due to this global warming and other you can get negative effect of this, because we are using fossil fuels for last more than 50 years. So we already polluted our environment. Because of this, already our nature earth have an imbalance. So because of this, we are facing lot of environmental disorders due to this global and other effects. So what is the solution to bring back our nature earth? Because I already stressed it before, these fossil fuels are availability is limited. Once it is finished, so we will not get any resources to produce our energies. And another thing, if you are burning and burning and burning these fossil fuels, it inevitably it will affect our environment. It spoil our natural life. So the only solution for to bring back our nature earth in old conditions. So we want to switch our energy needs from fossil fuels into renewable energy sources. So the renewable energy sources, it is available everywhere. You can get every day. So you can get back. So a lot of renewable energy sources are available in our environment, like solar energy. So every day sun is shining, sun setting. So you have a cyclic sunshine and sunset. So you have enough number of energy in the sun. So we can use this sun energy to make energy. Similarly for wind. So we are not facing any geothermal energy. If you are going Europe, some other cold countries, from down of earth, you will get a lot of heat resources. You can say like hot suns, water fields. So this generating lot of heat is. So from this heat, you can generate the electricity. Like we are using hydro energies in our different dams and other things. So we have a lot of oceans because 70% of things are covered with oceans. So we have a lot of ocean energies. Apart from this, now we are using biofuels. We are using ethanol. We are adding ethanol in our fossil fuels to minimize the use of requirement of fossil fuel from other peoples, and as well as to minimize the emission of these greenhouse gases. So many bio-based gases or biodiesels, everything is extracted from the biomasses. So now we are generating biomasses. Other than that, so if you are what we seen before, this type of energy is in large quantities. Even though the sound and vibration energies are existing everywhere, even though it is small, but it is useful for some type of applications. So today's presentation is mainly focused on this small amount of energies which has been used in different applications. The slide is visible. Slide is moving.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So there are lot of vibrational and other resources are available in our environment. So you can take RF energies. So we are producing lot of signals for mobile communication and that is. So it produces lot of RF signals in our environment. Similarly, lot of vibrations because of vehicle movement, wind movement, sound, so many vibration energies. So these energies are very minimum, even though these energies are enough to operate many electronic gadgets which can capable to operate very long time, very sustainable. So the down graph indicating the different electronic gadgets and our requirement. If you are taking micro PC to laptop, the energy need from 10 nanowatt to 10 watts. So the different energy sources can be used for different electronic gadgets to operate. So if you are taking now, the portable PV photovoltaics. So you can fix it in your backpacks. So it can be used to charging your mobile phone or your laptops and so on, because it is minimizing the uh, uh, device structures. The power consumption also decreases. So many small devices, like you have a smartwatches, it's need very minimum power. So this type of small electronic gadgets can be operated through this type of energy harvesting devices. Okay, so many applicability of this vibrational energy harvesting devices are to sustainable operation of many electronic gadgets. Now people are talking about AI, IoT. So what is the need of IoT devices now? Because after this corona, it teaches things. So we need to go for everything remotely. Because, for example, before corona in 2019 and 20, so mostly we will visit the hospital, we will see the doctors, he will write a prescription, he will suggest to go and take this type of test and everything. After this corona, it teaches many aspects, because doctors and expertise are available in the world in very far away. For approaching them, it's very difficult. If you are going directly and meet them, getting appointment, and it's take very long time. It's make your disease or other factor, it is progressing. After this corona, the telemedicine industry is grown enormously in India, particularly India, because our people are not aware of this telemedicines. So now you can consult the doctor anytime through mobile app or mobile phone. So how it bringing technology into very viable and very easy accessible means. So we have a lot of monitoring devices which can be able to integrate it with our internet. So if you want to monitor your ECG or your blood pressure, now everything coming into app and small electronic gadgets. If you are combining these two, your doctor will see from anywhere in the world to monitor your health in 24 into 7. This advancement in electronic devices and integration of these electronic devices into internet, which makes more easy and more accessible, and you can monitor your health condition in 24 into 7 in 365 days. So you are under monitoring in every time. So which makes even doctor or medical industries easy to diagnose and easy to prescribe the medicine at right time. It will not allow the progress of your diseases in normal to in very worst conditions. So many IoT devices are existing in our day-to-day activities. So we know the best example is smartwatches. So now you can monitor your blood pressure, your glucose level, your heartbeat, so on. So before it is not like that. After this COVID, we came to know the importance of monitoring our own health. These IoT devices are bringing these things very easily to all people. The IoT devices are not restricted only with the smartwatches. It can monitor your ECG, health condition, your baby health progress, your mental health, so many. And your it is not only restricted with health, it can implemented in different field, like you are using fitness, whether you are fitted or not. So many things. Similarly, which can be implemented in industries to monitor very closely with their production, quality, and as well as the safety concerns. So that is the we will call industry 4.0, because it is everything automated. It is put into internet, so you can monitor in anywhere in the world to see the production and as well as the quality of the industry productions. It is not only restricted with health and industry, it can implemented in military also. So now GPS, you can track the people, you can monitor their health condition and so on. So many the Internet of Things are emerged. So these type of devices need very, very small energies. Because, for example, we are a military people. You are in a very high altitude. How you get energy to operate this type of devices? If this device you have a capability to produce energy from this their environment, like through PV or it through body motion and other aspects, so no need to charging. So it will automatically charge through the environment activities. So which will help or which will propagate their energy loss, or it will take this devices operation for many days. So many places this vibrational energy harvesting is very useful. Basically, the vibrational energies are harvested using three different principles. So initially, people are using with electromagnetic mechanism to harvest the electricity, because so the electromagnetic. So when you are changing the magnetic flux in the electric field in the magnetic flux, so it will produce as the EMF. This is well-known principles. So using this electromagnetic mechanism, people are able to produce as the electricity when you are walking or when you are running, because it altering the magnetic flux in the devices, it produces the EMF. They can produce as the electricity. Later, people are using some specialized material that is called piezoelectric material. It is nothing but it is a non-centrosymmetric crystalline material. If you are taking its crystal structure, what will happen? The crystal atoms are not properly oriented. So it is called non-centrosymmetric. It is not placed as a center. Some of the atoms are misplaced from its original positions. So because of this non-centrosymmetric, what will happen? The polarization will happen in this type of materials. So what is the advantage of this polarization? This type of material, when you are applying external mechanical pressure, what will happen? Due to this misplacement of this ions, it will produces the electric potential. This electric potential will drive the electron for generating the electricity. So similar kind of principles they are using in triboelectric materials, which is nothing but tribological is nothing but the friction related things. If two different materials are friction each other, what will happen? It produces the electricity. So based on these things, people are harvesting this vibrational energy. We can see one by one these mechanisms. So I already told the piezoelectric. The piezoelectric effect, it is not only used for to generating the electricity. It have lot of day-to-day applications. Our homes, how we are using lighter. So lighter is made up of with small quartz crystals, which is nothing but the piezoelectric materials. When you are triggering, what will happen? Due to this mechanical strain, this quartz crystal start to make a spark. This spark is used to glow or fire your gas stoves. So this is the simple example for piezoelectric effect. And you see lot of transducers. Now you see lot of greeting cards with some musics. These greeting cards with that speakers are made up of with these piezoelectric materials. These piezoelectric materials not only used for to generate the electricity, It is used for many other applications. It have two principles, two way it can use. You apply electricity and produce the mechanical vibration, or you can apply the mechanical force and get the electricity. So according to different application, this can be used for different applications. Now lot of actuators, which is made by piezoelectric materials. If you are seeing the down corner of this bolt, this is nothing but this is the device which can harvest the mechanical vibrations. It can store this harvested energy. So this is the commercial product which can be used to harvest the mechanical vibration to power up some small electronic devices. For example, now we are seeing in many places Wi-Fi. So Wi-Fi need to power to operate. So you can fix this type of small energy harvesting devices which can harvest from our wind. So this wind energy can be converted into electricity. This electricity can be used to power up this type of Wi-Fi devices and other things. Not only this, see, some remote places you cannot able to access, or you cannot charge every frequent time to monitor, or like you want to monitor your bridge. So whether this vibration is okay, this quality of the bridge is okay. So you cannot replace every time. Go and sit, you can replace your battery or anything. So this type of non-accessible area, you can couple with this type of piezoelectric energy harvesting devices to harvest the vibration energy, and it can be used to monitor this type of unaccessible devices, like monitoring the bridge and some other electronic devices. It can be implemented in different configurations. So it's different configurations. Sorry. Next one is electromagnetic harvesting devices. So electromagnetic, I already told, same. You want to change the magnetic flux in the device. Okay, magnetic flux, how it is coming? We are using magnet. So when it is moving, what will happen? It's changing the magnetic flux across the electric, across the your binding coil. Okay. So because of this change in the magnetic flux, what is going to happen? It changes the EMF in the electric coil. So because of your movement, automatically we know the magnet will be moved. So because of move, it changes the magnetic flux. So because of change in magnetic flux, you are using the electrical output. There's so many electric devices, the electromagnetic energy harvesting devices are manufactured, prepared, and used for different applications. Now, recently, people are preparing with anklet. So when you are moving, what will happen? Magnet will move inside the anklet. So it's altering the magnetic flux across this anklet. So because change of magnetic flux, it produces the electricity. So this electricity can be used for powering your smart devices or mobile chargers and so on. Next one is triboelectric effect. Compared to piezo and electromagnetic case, these triboelectric cases have more huge potential because I told you in piezoelectric case, you need some particular material that only have the piezoelectric nature. So that type of material only you can use for energy harvesting application. It have a lot of restrictions, like you cannot make your desired structure. And another thing, the type of ceramic materials are very hard materials and easy to brittle. So you cannot use for flexible or some functional applications. So it is restricted. And another thing, the electricity generated from this type of devices are very small. Very small. So So it is restricted with many actors. But in case of triboelectrification, it is a very simple one. In our day-to-day activities, we can see lot of electrostatic behavior in our activities. The best example is our body have electrostatic charges. If cold season, now it's a cold, we are using the sweaters. So what will happen after wearing sweater? When you are sitting with the plastic chairs, your hairs are attracted with these chairs. Did you think anytime what is the reason behind this? Which is nothing but the existence of electrostatic charge in your body, because when you are wearing with your wool things, it is touching with your body. So when you are moving, this wool with rubbing with our bodies, it produces lot of electrostatic charges. The electrostatic charges stored in our body, because this is electrostatic charge. You will think because of this electric charge, you will not feel any discomfortable or anything, because this is basically electrostatic charges. So it will not affect much our body. So whenever it is getting chances to discharge, it starts to discharge. Similarly, when children are playing with big plastic things, after few runs, their hairs are like vertical. Similarly, for comb, you can see this type of experiments in your elementary schools. So what is the reason behind this type of things? When you are rubbing two different materials, what will happen? The material have the tendency to get electron or lose the electron. So once it is gaining or losing electron, it is charged. It is surface charged. So because of this surface charges, so we are producing the electricity. Actually, you can see a lot of instruments which have more frequent friction with some other element. So we always have a earth. You are taking your motor or some other material which have a frequent friction with some other materials. So always we are putting the earth, because you want to discharge this excess electrostatic charges which is produced during the operation of your instruments. So basically, in the initial period, this triboelectrification is considered as a negative effect, because if you are not discharging this electrostatic charge, it will spoil the performance of your device. It will spoil your devices. So that's why people are putting earth to discharge this type of generated excess electrostatic charges. Okay. According to the capability of this material, which can be classified into two different varieties: electronegative, tribonegative material, tribopositive material. Because some material have a tendency to gain the electron, some material have the tendency to lose the electron. Based on this electropositivity and negativity, this material are classified. So if you are taking Teflon, PTFE, it is the highly negative triboelectric charge materials. If you are taking fur and hair, it is the highest tribopositive materials. The best example for electrostatic discharge is lightning. So because of this excess electrostatic charges, it is discharged as a lightning. This is the best example for triboelectric or electrostatic charges. So the triboelectrification will happen between the contact between two different materials, whether it may be a metal or metal insulator or insulator, may be solid with water or solid with gas or liquid, so many things. So if you are making frictions, if you make frictions, so it produces the surface electrostatic charges. So our main aim is to take this negative effect into positive way. So we are going to produce the electricity from this surface electrostatic charges. Professor Jetal Wang is working in Georgia Tech as a professor. He accidentally found this effect because before many people are using many polymers.
So sorry for the interruption. I
Yes.
think your slides are not moving. Yes, now it's okay.
Okay,
Yeah,
okay.
thank you.
No, if it is not moving, please inform me.
Sure, sir, sure.
Okay. So the Professor Jetal Wang have first invented this triboelectrification in two different polymers. Nothing but he simply take two different material. One is krypton and another one is PET. So what he will do, he rub these two materials because each material have a surface roughness. When you are making friction with these two material, he found the production of electric voltage and as well as current. So this is the basic studies he studied to show the generation of triboelectricity in the two different polymers. After the invention of this triboelectrification, this field grown like enormously. It is implemented in different applications, different perspectives, different ways. So we are going to see few of them in this presentation. We know. So when you are making rubbing or contacting two materials, we are saying generating the electricity. So we need to support with some model or theorem to support how this charge transfer or electron transfer will happen. So the different models are developed to showcase the production of this triboelectricity or the conduct electrification process. So I already mentioned the conduct may be solid contact. Two different solid substrate can contact each other. It can produce triboelectrification. The slide is open. Okay, it is visible.
Yes, sir, yes, sir.
It is not only restricted with solid. Maybe solid may contact with gaseous phase, or solid may contact with liquid, or two liquid is contacting with each other. So the any possibilities it start to produce the surface electrostatic charges due to the transfer of electrons. There are different models which can support the generation of electricity in the two different materials, maybe solid or gas solid gas or solid liquid. So basically the simple model they are proposing is metal dielectric models. So one side is metal, so another one is dielectric material. It is the highly insulating materials. So what is happening, so due to the friction or due to the surface nature of dielectric material, so it have a lot of defects in their surfaces. What will happen, so you know metal there was no band gap. It have a Fermi level. So the Fermi level is nothing but the level the electrons are filled. Okay, state. So what will happen when it is contact between metal and dielectric things? So due to the existence of defects or surface you can say the defects. So what will happen? The band is bending. So when Fermi level of your metal is less than this defect level, what will happen? The chances of electron from metal to flow from metal to your dielectric. So because of the flow of these charge carriers from metal to dielectric, it produces the potential on metal and as well as the dielectric. Because of this charge transfer, it produces the electricity in the your outer circuit or anything. Similarly, another things, if two materials are two dielectric material, that means that is high surface insulating materials. So this type of material is surface state models, because one material have a surface state is less than another material, automatically it have a two different potential difference. it have two different surface, different states. So because of this surface difference, it start to flow the electron from higher level to lower level. Due to this transfer of electric charges, it produces surface charge uh, density. It will alter the surface charge density alteration. Because of this, it produces the electricity. Similarly, like electron cloud model or interatomic interaction. So when you are bringing two material into nearer by, what will happen? Because of force, the distance between two material nucleus will be different because of this external force. Due to the change of interatomic distance, it will produce the potential difference across these two material, and it will drive the charges over the electronic circuits. There's so many models are developed to support the development of electrostatic charges over the two different materials. So slide is visible.
Yes, sir.
So after invention of this triboelectricity, people will say this is for R&D purpose. You know, Disney first started to show the potential of this triboelectrification process. What he did, he took simple PT PT layer. Okay, he coated with metal strips. What he done, using this triboelectric layer in different aspects. So he may rubbing with the electrode surface, or he is contact, non-contact, and he is rotating. Due to these different activities, he can able to produce the electricity. So if you want to show really to attractive, if you are showing electric pulse like 200 volt, 210 volt, like current value, no one will interested. What he did, he started to make interactive things, like using this generated energy. He glowed LED, he displayed with some letters, and he produces some rotating fan. So like this type of interactive things he made. So he made triboelectrification as a reality. You, with the help of some rectifier or some electronic gadgets, he made this generated electricity into some like interactive things. So this is the first demonstration done by Disney using and from this demonstration people are aware. So this tribal electrification have more potential in the future for many other applications. So he demonstrated like to blow LEDs, glowing letters, using this rubbing or rotating with these two dissimilar polymers. Basically, this tribal electrification will happen in 4 different modes. I already told this is the contact and separation of two different materials. So it can be classified according to it is contact mode. So one is contact separation. So touch and open, touch and separation, touch and separation. This is basically coming under contact separation mode. So where you can use this type of principle means if you have a high vibration. For example, you are using your vehicles. So vehicle when it is traveling, it produces more vibration, more extreme vibration. When your industry machines are operating, it produces more vibration. For that case, you can use this contact separation mode to generate the electricity from this waste vibrational energy. Similarly, lateral. So because all the application will not be same like contact and the separation mode. Some cases it may be like it is touching with each other. So like if you want to make our body, our dresses, you want to generate electricity when you are moving using your clothes. So your clothes is always touching with your body. So it is a lateral sliding modes. It can slide each other and it produces the triboelectric charges over this material. And freestanding mode, that means some other things it will external body will touch and go, that type of things. It is called freestanding mode. Some cases single electrode mode. It is also similar like freestanding mode. So compared to all other things, this freestanding mode have a higher efficiency. It can generate more triboelectrification than other modes. These are the different modes utilized to generate the electricity. So we want to know what are the basic things to produce the triboelectrification. So basically everybody know the Maxwell displacement, Maxwell law. So here also the most of the charge transfer is nothing but the electron transfer between the one material to another material. So here mostly the current is produced because of the displacement of this electric charge, that is nothing but electron. Okay, so if you want to produce this good triboelectric energy harvesters, it needs some good properties. That is nothing but your surface should have a higher surface roughness. So what is the use if it is surface is more roughness? If surface is more roughness means your contacting area is more and more. So your contacting area is more means you are producing more and more friction on your layers. So the surface area is one of the important parameter to produce more surface charge density over the triboelectric layers. And another thing, the material also it have a tendency to produce more electron, or it should have the capability to accept more electron. That means it is a tendency for electronegativity or tendency have more electropositivity. So if it is more electronegativity of that material means automatically your charge density will be more. Another factor, roughness, material roughness. So your surface area is more means definitely your surface roughness also more. So more roughness means more interactive area. So it produces more surface charge density. Similarly for dielectric properties, that means your material have a higher insulating property than other things, which will build up more surface charges during the electrification process. So there are a lot of techniques are used to produce as the surface modification. We know normally if any polymer, any solid substrates, the surface have its own uniqueness. If you want to increase the surface properties, you need to modify that surfaces. Then only you will get more. In case of this application, you will get more charges. Okay. There are many techniques people are following to make surface modification. We can say surface functionalization process. Like you can use some chemicals to modify the surface. You can make open hydroxyl group, ether group, thiol group. So you are modifying the surface of your material through the chemical functionalization. Or you can make more surface roughness through you make more micro and nano patterning over the surface. You produces more surface roughness. Other way you can you coat new materials, high like a dielectric materials or highly surface like you can surface functional materials. It have a more tendency. It have a more open groups like fluorine, hydrogen, oxygen, nitride. This type of functional materials coat over the your materials, and you can engineering with the different dielectric materials, different dielectric materials you impregnated with these materials to make more and more surface charge carriers. Okay. Basically, the surface modification done by chemically as well as physically. How physically you are making? So surface modification, nothing but you have smooth surface means you want to make more roughness. So physically how we are making, you make one template, you can replicate the template into some other surface. So that means you are making in different surface roughness. For example, you see the figures A, B, C. So it is a different surface texture. So it produces the different surface contact area, different roughness. Because of this different surface roughness, it produces different charge density. Similar way, you can use ultra fast laser or etching technique to etch your surfaces and make more surface roughness. So like that, you can make surface more roughness, different surface textures to make more surface to produces more surface charge density. So like that, that is physical method. Like chemical method, also you can use different copolymers to polymerize over the surface to make different surface structures. So here they are using polystyrene black with PDMS. So because of different molecular weight of polystyrene with PDMS, the assembling of this polymer is different according to its molecular weight. So if you are seeing with a different molecular weight like is 45%, it is producing like a dot-like structure. If you are increasing the molecular weight of your polystyrene, it produces different like grass-like structure, nanomer structure. So you can alter the surface self-assembling nature through the different parameters like molecular weight and ratio of these two different polymers. So like that also you can produce as the surface roughness to make more surface charge densities. And another way is you use like ionization process. So you want to surface treat with different ions or plasma treatment to make surface more dense to some other polymer surfaces. Like you can treat with ammonia based or oxygen based, argon based, so many different techniques to make surface more charged things. So if you are making with more surface charge, so it automatically produces more surface density and it will produce more electrical output in case of if you are going for nanogenerator applications. Similarly, people are using with different etching techniques to make different surface texture like nanowire, polymer nanowire, or nano seeds type of different structures they are using for this energy harvesting applications. Similarly, they are using different chemical process. They will modify these surfaces with different electronegativity, electropositivity to generate different charge densities. So until now, we are seeing lot of ways to produce us the higher surface densities. That means charge density. What are the way you can improve the surface charge density of your polymers? Now we are going to see. So you are producers the high surface density materials. You are making devices. So where you can go and use this type of things? Because I already stressed this vibration source have enormous resources in different way. So it is starting from vibration, wind energy, wave, when you are walking. So many resources are available in our environment. So this type of nano generated device, because this is a polymer material, it can be easily adapted in any structure, in anywhere. So it is the main advantages of this triboelectric nano generator. You can implement anywhere to produce the electricity, and you can use this generated electricity for different purposes. So many applications are evaluated based on their output performance, device configurations, and it can be used in different sectors. It's not only for to produce electricity. This triboelectric nanogenerator itself, it acts as a sensors to sense the vibration, or you can use to sense the wind. So many applications. So here we are going to see one by one application, few of the applications which are mostly influenced in the society. So this is, it's not only used to use for electricity generation, it can implemented in different way of harvesting the energies. So here you are going to get the vibration energy into electricity. So first, I'm going to discuss about the healthcare application. How we are going to implement this type of triboelectric nanogenerators for healthcare sectors. So I already stressed this triboelectric nanogenerator is nothing but it is made up of two polymer sheets. Okay, these two polymer sheets are making contact with each other through rubbing or contact or separation, any other mode, it's generating the electricity. So everyone aware of that pacemaker. So pacemaker is used to stimulate your heart when it is required to stimulate. Okay. So pacemaker is mostly used. It is operated with small batteries. Okay. At present scenario, the battery of this pacemakers are replaced in some defined period of time, like 10 years, 15 years. Once you want to replace battery, how we are going to replace battery means you want to reoperate that one and you take out your pacemaker and replace the battery in your body. So what is the happening of frequent replacements? Because if you want to replace, you want to go for hospital, you want to do surgery, you are putting more effort, more money on the replacing of these devices. When you are putting some devices which can harvest the energy or it can produce the electricity and operate your pacemaker for very long period, means you are reducing your cost of operation, hospitalization, and failure of these pacemakers. So many things. So people are implementing the triboelectric nanogenerator to monitor your heart functioning, and as well as it is used as a sources for to power the pacemakers. So which is nothing but the plastic polymer films which have highly comfortable with our body. It will not affect our body. So people are trying to manufacture this type of triboelectric nanogenerator which can monitor. Here it can act as a sensor to monitor your heart functioning. So if you have any deviation in your heart functioning, it will intimate it to your doctors. So your heart is somewhere dysfunctioning. So you need medical attention. So here this nanogenerator is used to act as a sensor to monitor your heart functioning, and as well as it is used as a sources to provide the power to your pacemaker. Similar way, I am discussing in first itself self-charging, self-powering. What is the self-powering? The concept is self-powering. You don't need to give any external power to operate any electronic devices. So what are the power it's required? It can produce us from itself. Okay. For example, you are using your smart watches. Okay, it needs power to operate. So if you are coupling one nano generator with this your smart devices, what will happen when you are moving? So it produces the vibration. This vibration is producing the electricity. This produced electricities are stored in the energy storage devices, which can be used to operate your electronic devices. It's not only for your smart devices, which can maybe your sensor, which can monitor your heartbeat, your body movement, so many your blood pressure, so many things. So when you are coupling this mechanical energy harvesting devices with energy storage device and functional electronic devices, the whole system is called self-charging power system. So it charges its own environmental activities. Okay, so it can assemble in different aspects, like single device, so which have both energy storage device and energy harvesting device, and it is integrated with the electronic gadgets. So many this type of integration will be possible to operate self-charging, self-powered system functioning. Okay, similar way. So a lot of textiles are now bring back smart textiles. So now I think people are aware of smart textiles, which can produces heating and cooling. So because for us, no problem. We are in a good climatic conditions. If you are going for Himalaya, it's extremely cold conditions. That means your body need heating to keep your blood flow should be normal. Okay, now what people are using? They are using smart dresses, textiles. That means the dresses are made up of some metal plates. Okay, it is powered by electric, like batteries. So what will happen because of these metal strips? You are applying electric voltage. It start to produces the heat. So this heat is making your body as a warm. Okay, that's why people are surviving in very extreme cold condition. If you are going in very hot conditions, your body needs some cooling. So people are using material with smart materials which can produce us cooling your system through the electricity. So now smart textiles with multifunctional operation, it can monitor your heartbeat, your blood pressure, and so on. So now many electronic devices are integrated with smart textiles to functioning as a smart textile operations. So the nanogenerator, triboelectric nanogenerator is the best sources for any this type of smart applications. So which can be used as a power source to power up any electronic gadgets. So these nanogenerators are not only restricted with this. You know, now air pollution is another hurdle for all human beings. So we are facing a lot of the pollutions, air pollutions. Because of this, we are getting more breathing issues, any problems. So we know these nanogenerators are producing very high voltages. So which can be implemented as a remediation for the pollutions. So basically, how we are treating our gases, our environmental air means. So nothing but this is arc discharge phenomena. Nothing but it is a highly biased conditions. So what will happen? You are ionizing your pollutant. So because of this ionization, these charged particles. So when it is moving across the metal grids, so because of this ionized this metal impurity particles, it will settling over the your it is collected over the metal sheets. So same principle here it is used. Here the carbon electrodes are used to produce the high ionic sources. So the nanogenerators are producing very high voltage. That voltages are applied to this type of carbon filaments. What happens? These filaments are highly biased, so high potential. So because of this higher potential, what will happen? These carbon filaments are start to ionize in the air around our atmosphere. Due to this ionization, these particulates are ionized. So because of highly discharged conditions, it will make more ionized particles. So because of this ionized impurity particles, it's moving from this ionized portion to the metal filament. So the metal filament is biased one, so it will attract this ionized particle. That means it is filtering the air particles. So for the figure E to F, it is demonstrating this nano generator will purifying our volatile air. So if you are seeing first one, there was no operation of triboelectric nano generator. So after 60 seconds also you can see the fog, white color fog. But if you are seeing a figure, it is operated with tank. Okay, and tank is operation. After 60 seconds, you see the clear things. That means this air impurities are removed due to the ionization process. Similar way, this nano generators are used to fabricate the portable water purification systems. So because now water discrimination is more and more, so we are getting more polluted water. So we need more specialized things to filter our water. So this is a very simple techniques. This is called disinfection process. Nothing but you are applying the high potential across the two electrodes. What will happen? Because of this potential, what will happen? It will start to kill the bacteria due to the electrode disinfection process. So this is nothing but it is made up of coaxial tube. So it is made up of copper plate. So center is one electrode. So you are applying the potential which is generated from the triboelectric nano generator across this coaxial cable and as well as the outer electrode, copper electrode. What will happen when you are passing the water across this tube, coaxial tube? What will happen? Due to this electrical potential, due to the electrical potential gradient, what will happen? This bacterial cell structure will be destructive and kill this bacteria. So if once it is killing means after the end of that outlet, you will getting the pure water, clean water. You can use this type of things for portable water purification applications. Similar way, these nano generators are used to purify the air filter. It acts as an air filter. Here they are using PTFE based beads. When it is making vibration, it is surface charged. So because of surface charge, it will attract the all dust particles and it will settle the all dust particles. So it have that tendency, can have a tendency to collect all different types of impurities. And similarly, the nano generators are not only used for other application, it can be used for to make IoT applications. Here I am very simply I am going to explain these things. So nano generator here, so many pyrolysis people, they cannot even able to communicate with other people because they cannot able to communicate through their mouth or hand, other things. So for that cases, you can use this type of triboelectric nano generator to communicate peoples or controlling some electronic devices. Here they they use electrooscillogram techniques, like it is one type of ECG. Through your eye blinking, you can pass your information or you can able to control your electronic gadgets in and around. It is nothing but the output is generated from blinking of your eyes. So these signals can be filtered and amplified, which can be inputted to some electronic device to control whether light off or fan on off purpose. We can use it. Similar way for communicating these words. So so many applications it can be used. Similarly, the nano generators can be used to detect the wind speeds. So mechanism is same. Generation of electrostatic potential. So through different process. So similarly, it can be used for making, say, electroadditive batch application. So the application of triboelectric nanogenerators are not restricted with one or two. It have a enormous applications. So this talk today, I'm going to give you some insights into the importance of this type of energy harvesting devices. So like you people, young minds, we can implement these things for various applications. So nano generators have a more perspectives in various applications. Even though it have a lot of things, it's need to be improved further for real applications. Like I already told, the surface charge density need to be improved further. And another thing, this is highly depends upon the environmental. Like because of this is surface charge, the surface charge will be degraded when it is high humid condition or high like volatile environment. So we want to take care of these things. We want to improve further in these aspects to get good application in near future. Apart from this, for my group, working in two aspects in the developing of electrode materials for energy storage applications, and another way we are working waste plastic for energy harvesting applications. So people are aware of energy storage device. The device it can store the electrical energy. So the basically now people are using batteries and supercapacitors to store the energies. So I'm not going much about the batteries. So people are know much about the batteries. So we are working on the supercapacitors basically. So we are working on the uh, field, the development of carbon-based materials to generate the use for making supercapacitor devices. So basically, the supercapacitors are classifying based on the energy storage application. They are called EDLC, electric double layer capacitors, pseudo capacitors, and the other one is hybrid and battery type. So here nothing but electric double layer. Here the ions, electrolytes ions are absorbed on the surface of electrode material. So absorption, desorption will happen during the charging and discharging process. That is basically EDLC supercapacitor. Most of the carbon materials are operating under the EDLC applications. In case of pseudo capacitor, it is slightly different from EDLC. Here, the intercalation will happen. So electrolyte ions will go inside the electrode material and store the charges. Here, it is not like a battery, but the intercalation happening on the surface of the material. So it will not alter any structural changes in the materials. The hybrid material, which is nothing but both, it will have the battery behavior and as well as the supercapacitor, that is EDLC behavior, the type of material hybrid mechanism. Battery is nothing but purely intercalation. It's like a lock and key. So one lithium is going inside means it changes the crystal structure of your graphite. When it is discharging, so it will change its crystal structure. It's like a key and lock method. So for this purpose, they are using all the bio-based materials to produce the carbon materials. So we are using very different bio mass sources for producing the activated carbon for supercapacitor applications. So this is the SEM image which we made activated carbon from the shrimp materials. So we are tested our fabricated electrode in different electrolyte. It's showing good performance, which is
Sir, excuse me.
yes.
Yeah, your slides are not moving. Yeah, now it's okay.
Okay.
Okay, sir. Okay, sir. Please.
Okay. Now it's moving.
Yes, sir.
Yes, sir.
Okay. Another part of our research work is based on the development of nano generator. So we know that a lot of plastic waste is exists in our environment. So a lot of plastic materials. So you can say from PET, PHDPE, PVC. So basically, I am belongs to plastic industries. So I need to do something betterment of people. So I selected different waste materials which can be used to make a triboelectric nanogenerator to produce the electricity. So we have collected a different variety of plastic materials because I already told in initial itself. So each material have its tendency for getting electron or losing electrons. So the each different plastic material have the different electronegative or electropositive property. So we want to analyze which one is the best for this energy harvesting applications. So we are collected many different varieties. So we are processing that one and making into film, okay, and making physical method to make surface more roughness. Using this type of devices, polymer films, we making nano generator devices to produce this electricity. Until now, the performance of the fabricated devices are not up to the mark, but what we found out, it is have the potential to generate the electricity. So this is the sum of the electrical output which is generated from PP waste. So polypropylene waste with aluminum as a metal electrodes. So we have produced some amount of electricity. So it's need further improvement to get a good output for some more good, reliable and repeatable output for some smart applications. So we have different plans to execute this type of things in near future. Thank you. Thank you for your listening. Thank you so much. If you have any question, please ask me.
Thank you, sir. It was a wonderful session. Now the session is open for discussion and clarifications.
Any question? If you have hesitation to ask question now, so I did my email ID. Anytime you can contact me. Please, any question? Please ask me.
Participants, kindly ask your doubts and clarifications.
If you have any question, also please write to me.
Sir, there is one question in the chat box, sir.
Yes, madam. Can you ask me? I could not find it.
Sir, Neetu is asking that, sir, out of the different surface modifications, which modified structure is found to possess best output performance for energy harvesting applications?
No, actually, madam, see, according to application and making large scale. Okay, each technique have its own merit and demerits. We cannot say this method is best for this method is best, because according to our need or where we are going to implement, according to that, the method of surface functionalization or modification is differ. If I want to make big large area, I cannot sit with the chemical method to modify that things. I hope my answer may be clear.
Participants, any other questions? Sir, I think there is no more questions, sir.
Okay, madam. Okay, madam.
Thank you, sir. Your talk was really thought-provoking. We got some light towards the areas like piezoelectric materials, triboelectric materials, and role of charge modifications for charge movements in the energy devices. Thank you, sir.
Thank you, madam.
Participants are asked to have a break for 15 minutes. Kindly do not leave the link. The next session will resume at 12:15 p.m. Participants, kindly do not leave the link. Kind attention to the participants. Attendance link will be shared at the end of the second session. Hope the participants are eagerly waiting for the next session. A genuine smile of welcome can make a bad day into a good one. In order to welcome our resource person of this session, I invite Mrs. S. Mangekarasi Madam, Associate Professor, Department of Chemistry, JKK Nadaraja College of Arts and Science.
Good afternoon, everybody. I deem it a great pleasure to welcome you all to the international seminar on energy harvesting and sensors. On behalf of PG and Research Department of Chemistry, JKK Nadaraja College of Arts and Science, Kumarapalayam, it's my privilege and honor to welcome our today's resource person, Dr. R. Parthiban, Senior Synthetic Material Chemist, Nanoco Technologies Limited, Manchester, UK. Even in his busy schedule, he has given his consent to act as today's chief guest. Thank you, sir. I take the privilege to introduce our today's special speaker, Dr. R. Parthiban, Senior Synthetic Material Chemist, who is qualified with MSc Chemistry in Madurai Kamaraj University, Madurai, PhD degree in Konju National University, South Korea, postdoctoral researcher, DGIST, South Korea, RSc Researcher Mobility Fellow, University of Glasgow, UK. He is gold medalist in MSc Chemistry in MK University. He is currently working as a Senior Synthetic National Chemist, Nanoco Technologies Limited, UK. As a material chemist, he has more than 10 years of experience in designing, conducting, and leading research projects in the area of displays, photovoltaic, sensors, and catalysis. He is an enthusiastic collaborator and learner. Let me highlight some of his achievements. He drove multiple projects with international and national partners on nanomaterials for energy conversion, established solar cell fabrication unit during his research. He led a project worth of $5 lakhs on luminescent cadmium-free quantum dots, leading to the preparation of green and red indium phosphorus quantum dots. To add feather on his cap, he has 6 patents and published 27 articles in peer-reviewed journals. He received Best Researcher Award in 2017 and Best Poster Award Samsung QD Forum in 2017. His current area of research includes synthesis of visible and shortwave infrared light-emitting heavy metal free quantum dots for display and sensor applications, developed and scaled up a process up to 2L in R&D and transferred the technology for production, optimized a process that reduced quantum dots production time by 2 days and resulted in a substantial reduction in the production cost, writing investigation report, implementing control of substances hazardous to health, and performing risk assessment. Skills and expertise. Our chief guest has strong scientific articulation, communication, organizational, and team building skills. He has deep understanding of operational requirements for a successful research project and managing resources. He has comprehensive expertise for handling toxic and pyrophoric material, expertise in various synthetic methods such as hot injection and heat up synthesis, photovoltaics, light emitting diodes, and photoelectric device fabrication. We are very proud to have such a versatile personality as today's resource person. Today's seminar focus on the topic energy harvesting and sensors, which is very important and useful at present scenario. I hope that all would gain valuable information, knowledge, and guidance through his thought-provoking speech. Once again, I welcome you all. Now I request our chief guest, Dr. R. Parthiban, to deliver his keynote address. Sir, now the platform is yours. Thank you.
Thank you, madam, for the wonderful welcome. Sir, now the session is yours.
Thank you. Thank you so much for the nice introduction. And yeah, thank you for giving me some opportunity to share some of my expertise in quantum dots. Let me just share my window. You can... Can someone confirm that you can see the presentation?
Yes, sir. Yes,
Yes,
sir.
yes.
It's visible.
Okay, yeah, cool. Yeah, my name is Parthiban Ramasamy. I work as a senior synthetic material chemist at Nanocore Technologies for a little over 5 years now. My expertise mostly based on like synthesizing and scaling up colloidal monomers for various electronic applications. And at Nanocore Technologies, we mostly focus on displays and sensing. So yeah, I would like to introduce some of the aspects of colloidal quantum dots in these areas. The general outline of my talks. So it's going to be, first I will introduce some of key concepts in colloidal quantum dots. So what is the physics behind them and the structure and some of the history, how scientists came across these wonderful materials. Later, I will introduce some of the synthetic schemes for these colloidal quantum dots. Then I will introduce two key areas of applications for these materials. One in display and other in sensors. So this is going to be mostly kind of introduction to these materials and applications. There won't be much technical terms. And there will be some technical side of chemistry. So to give a brief introduction about Nanocore Technologies, we are a publicly listed company and in London Stock Exchange, founded in 2001 in Manchester as a spin-out from Manchester University. And we are one of the leaders in research and development and manufacture of semiconductor nanoparticles. And we pioneered the cadmium-free quantum dots, such as indium phosphate quantum dots. We've been researching indium phosphate quantum dots for like over 20 years. And we have like extended in intellectual property portfolios, like over 500 patents, and still few patents are pending. And we have a unique IP protected our scale-up capability. And currently we are working mostly on the next generation sensor materials. And very recently we won 100 million settlement from Samsung Electronics over our IP infringement. What they did, like we have IPs protecting most of the quantum dots productions. And yeah, they infringed our IPs and we went to a trial with them and finally we won 100 million settlement last week. Our core expertise is mostly material synthesis, and we do some surface chemistries, and we improve the process into scale up, and also we manufacture. We can produce kilograms of quantum dots in a day. And also we do some devices. And the main application we are focusing is sensing and displays. We also do little life science and also in the lighting. And yeah, this slide just summarizes my research experiences as the, as my PhD, most of my PhD, I focused on metal chalcogenide nanoparticles for solar cell applications. And during my postdoc, I transitioned from energy to quantum dots for displays and lighting applications. So I've been working almost 8 years with cadmium-free quantum dots, mostly on the indium phosphide, and very recently I work on indium arsenide, and I'm leading a research project in indium antimony quantum dots for sensing applications. I would say my expertise is synthesizing colloidal nanocrystals, and also I have proven record in scaling up them and taken into production. I have little experience in fabricating devices, but mostly my expertise is in synthesis. Okay, let's go into quantum dots. So this is going to be a little introduction about colloidal quantum dots. So what are quantum dots? Many of you may have heard about quantum dots. It may be new for some of you. First of all, they are semiconductor nanoparticles. So as a semiconductor, they have a defined band gap that can be changed for different materials with different compositions. And they are crystals and they are very tiny, 2 to 50 nanometer in size. So that's roughly almost 60 million times smaller than a tennis ball and 10,000 times smaller than a human hair and 1 to 5 times the width of a strand of DNA. The most amazing and interesting fact about the quantum dot is their size-dependent luminescence. They can emit bright colors across the whole visible region for the same composition, but you can simply change the size of the quantum dots and get the colors from blue to red for the same composition. And they have several advantages over organic dyes. If you look at the organic dyes, the blue line here in the spectrum, they have a very broad emission. Like as you can see, it starts from 500 nanometer and goes all the way across 700. So the emission is not pure. When you want for display application, you need to see the pure colors in the display. You don't want to see green with the yellow or orange shade or red with the green shade. Whereas with the quantum dots, you get very narrow emission. It's color pure emission from that. And if you go with the absorbance, as you can see, the dye has very narrow absorbance. It can't absorb broad lights. Whereas with the quantum dots, it has a very broad absorbance. So you can excite this quantum dot with any light from 300 nanometer to 500 nanometer still produce.
Excuse me, Dr.
Yeah.
Parthiban. Either you are stick in first slide or you are moving.
Oh.
Either you are stick in first slide or moving because it's still
I'm
in
moving,
first
I
slide.
guess, like
Okay.
there is some issue.
Maybe.
The slides changing or still
No,
stuck?
no. It is not changing.
Oh, okay. Let me stop sharing it and try to share again. Okay. Okay. Can you see the slides? Is it changing?
Yes, now it is
still...
visible. Yes.
Yes, sir. Yes, sir.
Okay. I guess it's moving, right? Okay, cool.
Yes.
Moving.
Please proceed.
Moving, sir.
Okay, yeah. I'll just... Okay, yeah, as I was saying, like quantum dots, they are semiconductor nanoparticles and where they're tiny in size, 2 to 50 nanometer. And yeah, the best part about the quantum dots is the size dependent luminescence. You can just simply change their size and get luminescence from blue to red. You don't need to change the composition or anything. Like you can just change the size from 2 nanometer to 5 nanometer and produce all these visible colors. As I was saying, they have obvious advantages over organic dye, such as very narrow emission line widths and broad absorbance. So you can excite these quantum dots with any wavelength of light from 300 to 500 and still produce a narrow, bright emission. And their band gap can be easily tuned by simply changing their size or changing the composition, and you can tune the absorbance emissions from visible to near IR to mid IR range. And compared to organic dyes, they are highly photostable as they are made of inorganic nanoparticles, and they are very stable in the luminescence conditions. And they have high surface area, which can be helpful in different applications such as catalysis. Okay, I guess you can see this slide. And so why quantum dots? Why do we study about quantum dots? Like, where are they used? As I said, they have a size-dependent absorption and emission that can be used in various lighting and display applications. It can be used to light our house, and they are very stable and they have very long lifetime. And nowadays, they've been used in displays quite a lot, as many of you have seen QLED displays from Samsung and some other TV manufacturers. It's a very huge area of application there. And also you can use in mobile phones and in sensors. And they have excellent charge transport properties. So that can be used to make sensors and the sensors can be applied in food processing and augment AR, VR glasses, and also as a sensor like machine vision like for the autonomous vehicles. And the bright and narrow band emission can be used to make lasers. And they have tunable surface chemistry. You can functionalize the surface with various biomolecules and use for bioimaging of cancer cells and targeted drug delivery. One obvious advantage about colloidal quantum dots is they can be produced in solution. So you can like have a 500-liter reactor and produce kilograms of materials in one day. So that can be used for large area applications where you need like such as photovoltaic cells or solar concentrators. So it's not a one trick pony. You can have like with quantum dots, you can have applications ranging from electronics to supercomputing to bioimaging and also in energy as well, like solar cells. And yeah, they can be used in almost many fields. Okay, so it's a brief history about quantum dots. Can someone confirm you can still see the slides? Are they moving? Is it stuck? Okay. Okay. First, Russian physicist Alexei Ekimov, he was working with some of the copper chloride and cadmium selenide in glasses. And he observed they behave slightly different to what he was used to know. And they have like slightly different observed features. At that time, he didn't know what they are and how to explain these features. And later, fellow Russian physicist Alexander Efros, he came along and he first theorized the quantum dots. And he said like, okay, these absorbers are because of they are tiny, and also they are because the electrons are very confined in a state that leads to these optical properties which Ekimov observed. So he first theorized what are quantum dots. And later in 1983, American chemist Louis Bruce, he was fascinated by these observations and he tried to synthesize them in solution. And he first came up with a method to produce colloidal cadmium selenide in 1983. After that, like many researchers tried to synthesize and they all got some kind of properties, but the breakthrough came in 1993 in Bhavandi's group. He and his fellow PhD student Chris Murray, they developed a hot injection method where like they did the quantum dot synthesis at relatively high temperature, almost like 300 degrees Celsius, and then managed to produce very mono dispersed particles. So that's the starting point for the modern quantum dots, which are used in electronics and all the applications. They managed change the size of the cadmium selenide from 2 nanometer to 10 nanometers with very monodispersity and observe very high photoluminescence quantum yield. So that's again, generated lots of interest among scientific communities. And then the next 20 years, the quantum dot field exploded and became one of the mainstream in material research. So how do they emit light? Why are we seeing this different behavior for these tiny crystals? So that can be explained going back to some of the quantum mechanics, as many of us studied in our quantum mechanics class, particle in a box description. So it is a continuous band, like you don't have separate energy levels. And when the bulk semiconductor absorbs light, it generates electron and hole pair, and it has the freedom to move all over the bulk material as you have a continuous band. But what happens when you start to shrink the semiconductor into smaller size? Because each electron hole pair for each metal, they have defined size. But when you start to squeeze them and try to confine them in a smaller space, what happens is that energy level starts to split and you start to see the band gap increasing. So that's what happens in the quantum dots. When you start to reduce the size from bulk to nanometer, you are forcing the exciton and hole pair to confine in a very small space. So that leads to that brings the valence and conduction band to more discrete levels, and increases the band gap. As you can see, like when you decrease the size, the band gap just keep increasing and it spreads into more. So that's how they produce different colors, and that's how the band gap is changing. So when you make a 2 nanometer quantum dots, the electron and hole are very confined in that small space. So you have a larger band gap, and they absorb the blue light and emit the blue light. As the size gets bigger and bigger, they have little bit freedom to move along, and the energy gap decreases, and they absorb and emit red light. So the structure of quantum dots. Quantum dots have like 3 engineerable structure components. First is the semiconductor core, which is the key in the quantum dots. The size and shape and composition of the core material dictates the optical properties such as absorbance, wavelength, and where it emits and everything. And then you have the semiconductor shell around the core. The purpose of the cell is to protect the core from environment such as moisture and other chemicals. And also the thickness and the composition of the cell determines the stability and the optical performance of the core. And then you have the surface ligands. This can be organic long-chain aliphatic or inorganic molecules that passivates the core and cell material and functionalize the surface. And these ligands can be even biomolecules. And the purpose of the ligands is to stabilize them in colloids and also provide the solubility. As you can see, like you have core, cell, and ligands. Together they become final quantum dots. And as you can see from these TM images, and you have a core right in the middle, and you have a shell around the core. You can see clearly from these images. So this was like different kinds of quantum dots composition available. Based on the composition, you can broadly divide them into 2 categories. One is heavy metal containing, so which are toxic, and I would say like mostly high performing. So they are based on either cadmium or lead or mercury-based materials, and they have very high performance, but when you want to use them in commercial applications, people are moving away from using these toxic heavy metals. And these are mostly studied and like well-developed materials, especially for the cat selenide system. It is one of the most studied in the last 25, 30 years. And you can have emission from 450 nanometer to 650 nanometer, which is ideal for display application where you need blue, green, and red light to produce images. And you can have cat telluride system and doped cat telluride selenide system, and you can move the absorption to near infrared, which is good for biological applications. And then you have lead sulfide, which can absorb from 800 to 2000 nanometers. And this is the most studied for the sensor in the short-wave infrared wavelength. Then you have lead selenide, which can go from 900 to 3500 nanometers. And you have the mercury telluride, which can go almost like cover the entire infrared, like mid-infrared regions, like from 900 to 6000 nanometers. So all these visible emitting quantum dots used for displays, and this side of this material, like lead sulfide and mercury telluride, they are used in the sensing. And also you have these emerging quantum dots based on perovskites, and they have absorbance and emissions from 400 to 800. And one of the drawbacks of these perovskites is their stability, and people are trying to stabilize them for a very long time with minimum success. And going to the heavy metal free quantum dots, which is what I'm focusing on in all these years. They are free of heavy metals, so they are environmental friendly, non-toxic. There you have zinc selenide for the blue emission and indium phosphide for the visible emission. It can cover the range from 490 to 700 to 800 nanometers. So this is one of the most studied heavy metal free quantum dots. And then you have indium arsenide, which can absorb from 750 to 1500 nanometer. That is ideal for SWARE sensing. And you have the indium arsenic antimony or indium antimony, which can absorb up to 3000 or 5000 nanometers, which is again ideal for sensing. Here at Nanoco, we are focusing mostly on indium phosphide for the displays and indium arsenide and indium antimony material for the SWARE sensors. Let's going back to this section. I'm going to summarize some of the common synthetic methods to prepare colloidal quantum dots. And yeah, colloidal quantum dots have, like colloidal synthesis has obvious advantage over physical methods. So quantum dots can be produced by physical methods such as physical vapor deposition, or you can do molecular beam epitaxy. They are quite expensive and limited for the mass production. Whereas in the colloidal synthesis, you can just have a small reactor and produce quite a bit of materials. And again, they have obvious advantages such as you can control the size and shape of the particles. You can control the shape from spherical particles to one-dimensional nanorods to tetrapods to the two-dimensional nanoplatelets. So this shape control also like changes their properties. You can tune the properties based on the applications you need. And another advantage of the colloidal synthesis is you can impart quite few surface functionalities to these particles. If you want them to be soluble in non-polar organic solvents, then you can have long alkyl aliphatic ligands. Or if you want for some catalysis applications, you can just remove the ligands and put some inorganic ligands for the better transport. And yeah, if you want for some bio applications, you can make them water soluble, and you can also functionalize them with various types of biomolecule. So you can do lots of things with these colloidal quantum dots just by changing the surface. Another obvious advantage is that they are produced in solution, so they are solution processable. So you could process like large area devices using inkjet printing or spin coating or any other material like methods. They are quite useful and quite straightforward to produce devices. And yeah, again, as I said, like as we are doing in reactors, you can have a larger reactor, almost like at Nanaco we have 50-liter reactors, and Samsung they have 500-liter reactors. So you can easily produce kilograms of quantum dots in a day. So that's quite exciting, and that's not possible by physical methods. And in terms of synthesis, and most commonly used method is the hot injection synthesis. In the hot injection, what you do is like you take room temperature precursors and you just inject them to a very hot solvent, mostly like 250 to 350 degrees Celsius. You just heat your solvent to very high temperature. Then you inject your cationic and anionic precursor to a hot solvent. So what happens is when you inject our precursors, they convert into monomers, and the monomer concentration just increases. When it reaches a threshold for the nucleation, they start to come together and bond and form nuclei. Once the nucleus started to form, what happens is like the monomer concentration decreases and it goes into growth mode, and the nucleus start to grow from whatever the monomers left, consuming the leftover monomers. And as the time passes, when there is no monomer left, they start to ripen. In that case, the smaller quantum dots get consumed and the bigger dots grow. And this type of hot injection method is mostly used to produce cat selenide and zinc selenide quantum dots. And this is not suitable for large scale productions where injecting liters of precursor into hard solution is just not viable or just practically not possible. That's why we have this other system, like it's called heat up synthesis. In this system, what you do is you just mix all the precursor at room temperature. Then you just heat the whole system to final desired temperature. And yeah, in this case, you can have a very controlled reactivity. In the start, you have the precursors. As you slowly heat them, they start to turn into monomer. And once you have a certain monomer concentration, then they start to nucleate, and then they start to grow as the time progresses and the temperature goes up. So this is widely used in industries due to its simplicity to scale up. Yeah, all you have to do is mix them at room temperature, then heat. And in this case, the growth is controlled by changing the precursor reactivity and the surface ligands and the core temperature and how long you grow. It is widely used for indium phosphide, lead sulfide, and indium arsenide and copper indium sulfide, and some other quantum dots. There's also a new method which was recently developed by Talapin from Chicago University. What he did was like he used molten salts as a solvent. Molten salts are nothing but like a eutectic mixture of various salts. In this case, cesium bromide, potassium bromide and lithium bromide. When you combine them in certain ratio, you form a eutectic mixture, and they are solid at around like 250 degrees Celsius, and they melt and become liquid, and they are very stable liquid for very high temperatures. So you can use these molten salts as a solvent to produce quantum dots that are very difficult to obtain using traditional solvents-based method. Traditional solvents such as squalane or like on octadecene, they can go up to 350 degrees Celsius. Then they start to decompose since they're made of organic molecules. So you cannot perform the colloidal synthesis more than like 360 degrees Celsius, as most of the organic molecules start to burn at the temperature. Whereas in this case, like you first form colloidal nanoparticles in organic medium, then you exchange their surface with inorganic ligands, and you put them in the molten salts and treat them with, in this case, gallium iodide to dope the gallium. And you can perform reactions at more than 400 degrees Celsius. As you can see, as he saw, like he had the indium phosphide quantum dots, and he treated them with the gallium at 390, 420 degrees, and he successfully doped the gallium into indium phosphide quantum dots and changed their band gap from red emission to almost green emission, which is very hard in solution phase to produce this indium gallium phosphide. This is the first time he showed you can successfully dope gallium into indium phosphide at really high temperature. And another advantage of this method is like you can produce some of the challenging nitrate quantum dots. Nitrate quantum dots are very hard to produce under any methods in colloidal synthesis. But whereas using high pressure reactor at molten salts, the Alpine group managed to produce gallium nitride and aluminum nitride quantum dots in solution phase. This is the first time successful preparation of these quantum dots in solution, which is quite exciting. So going into some of my expertise, what I did in the indium phosphide quantum dots over the last 5-6 years. I'll just briefly explain the chemistry of indium phosphide quantum dots and why they are difficult to produce and how we managed to overcome these difficulties. As I said, indium phosphide quantum dots are non-toxic, and they are environmental friendly alternative to cadmium-based quantum dots. However, the emission performance of these quantum dots are slightly inferior to cadmium-based quantum dots in terms of color purity and the quantum yield. The reason for that is cadmium selenide is more kind of ionic in character. You can easily form bond between cadmium and selenide at lower temperature and lower reactive precursors. Whereas in the indium phosphide case, the bonds is more covalent in nature. So it is a bit hard to force them to bind together at lower temperatures. And also you have like very limited precursors that can produce phosphorus monomer. And they are mostly pyrophoric. That means that catches fire like radio. As soon as you expose them to air, then they just combust and catch fire. And most of them are highly reactive. So according to Lamber model, as I explained, like you go through the nucleation phase and you go into growth phase, and you need a constant supply of monomer for the nuclei to grow into monodispersed particle. But what happens in the 3-phase system, such as indium phosphide or indium arsenide, is since the precursors are so reactive, as soon as it enters the nucleation phase, all the precursor concentration depletes and you enter into the ripening stage where the smaller dots ripen and the bigger dots grow. That leads to polydispersity. That's why the emission color emission line which is not as good as the cadmium based ones. I did few experiments early on, like to decide which method is good for the indium phosphide, whether it's hot injection or heating up. In the hot injection case, indium salts are heated to 300 degrees Celsius, and trimethylsilyl phosphate, one of the most fluorophoric chemicals, injected into the hot indium permeate at 300 degrees. As you can see, like the absorbance spectra is not that sharp for the hot injected one, whereas in the other experiment I did, I took the indium permeate and mixed with TMSB at room temperature, then slowly heated to 300 degrees Celsius. As you can see from this absorption spectrum, they have very narrow size distribution. And yeah, this heat up is much better than the hot injection for the indium phosphides. Then when you try to make shell with zinc selenide and zinc sulfide over this indium phosphide quantum dots, they tend to broaden in the size distribution. And yeah, the maximum, the lowest full width half max color purity you get was 43 nanometer for this type of quantum dots. 43 nanometer is very broader than what they get for cadmium selenide. For the cadmium selenide, it is usually around 20 to 30 nanometers. So if indium phosphide is going to compete with cadmium, it needs to come below 40, like ideally 35 or even 30 nanometer, the emission line widths. In the next one, I changed the strategy a bit and developed a procedure to make zinc passivated indium phosphides. In this case, what I did, I had indium and phosphorus as well as zinc in the reaction mixture. When it grew, it formed like indium phosphide core passivated with zinc. And when you make a shell with these materials, you get a very narrow and bright luminescence. The full width half max decreased from 45 to 38, and a very high quantum yield of 71%. And you can change these precursor ratios and heating time, and you can produce from blue to green emitting indium phosphides, and some of them have like 35 nanometer full width half max. So they produce very pure colors. And yeah, one of the limitations of this heat up method is you can't produce a larger indium phosphide quantum dots. And for that, what I developed a SILAR method, so successive ionic layer absorption and reaction. In this case, you have a core quantum dots and you passivate the surface with more indium salts. Then you react with phosphorus, then you cool down, then you repeat the cycle and again and again. And as you increase the number of indium phosphide cycles, you can change the quantum dot size from 1.8 to 3.6 nanometer with better monodispersity. But one of the problem with this method is like you need to do the cycles heating and cooling. So that would take you more than 2 days to grow nanoparticle from 1.8 to 9, like 3 nanometers. So it's quite laborious and time consuming. And what I did later was to develop a seed mediated synthesis for the indium phosphide quantum dots. In this case, I first reacted indium and phosphorus to make seeds. Then while maintaining at higher temperature, I did was I fed more indium and phosphorus to the growing nuclei. I guess, yeah, if I can show you. Yeah, in this case, what originally happens was like you go to the nucleation stage and your monomers deplete and you go into phosphoripening. Whereas in this modified seed mediated method, you start to feed your monomers when the nuclei concentration drops. And by constantly feeding new monomers, you maintain the constant precursor concentration. That helps you to maintain the monomer supply. And you can just keep growing indium phosphide from like 500 nanometer to 700 nanometer absorbing with very high monodispersity. And yeah, this was one of the big paper in indium phosphide, I would say. And this changed the whole indium phosphide synthesis. Like now several groups are adopting and industries are adopting the seed mediated method where you just make seeds and continue to grow them. And as an advantage, like you can just tune the wavelength from any wavelength between 500 to 650 nanometer, and you can produce these beautifully emitting indium phosphides in a day. And they all have very narrow emission line widths. As I said, like after these papers and few more papers, seed mediated growth has become very popular to synthesize 3-5 quantum dots. And to go more into the details of this seed mediated growth and what's the chemistry behind them, all we are trying to do is avoid secondary nucleation when you feed. So what happens, like when you feed more indium and phosphorus precursor solution, you want them to go to the surface of the nuclei and react with the surface, then the nuclei grows. You don't want them to nucleate separately in the solution. That's called a secondary nucleation. When they nucleate separately, then you get like you already have a nuclei which is like, let's say 2 nanometer in size, and you produce new nuclei. They are smaller in size, and you end up with very polydispersed materials. And to avoid these things, like we have to have few things in mind. First is the quality of seeds. So you need to have monodispersed seeds to start with. If you have already polydispersed seeds, and they grow into polydispersed dots at the end, and they should be free from any surface oxidation, because most of the reactions happening at the surface. So it should be free from any oxides. And the precursors reactivity, you should have a quite high reactivity for the precursors you are adding, because as soon as it reaches the surface, it needs to convert into indium phosphide or indium arsenide and grow the nuclei. And the surface reactivity of the quantum dots, whatever the nuclei is growing, that surface should be active enough to accommodate the incoming precursors. So this can be achieved by tuning the precursor composition, changing the indium to phosphorus ratio, and the reaction temperature. The hotter you go, the more the surface become active, and how fast you add these precursors, whether you add too slow or too fast. So these 3 things are key, and you try to find a balance between all these 3 to get better growth. Could show some of the examples of some of the effects of the reaction temperature. Let's say, like in this case, we did experiments at 200 degrees, 240 degrees, and 310 degrees with constant addition rate. As you can see, at lower temperature, the surface is not active enough to accommodate the oncoming precursors. So it's for the seed, it was good, then it hardly grew. But as you can see, the absorption at 310 nanometer keep improving. That means it is producing indium phosphide seed nuclei, but it's just not growing on to the existing seed. So what happens is you just have your existing seed, its surface is not active, so it's not accommodating any oncoming precursors. So what happens is the precursors nucleate separately and start to grow. You end up with polydispersed material. At the end, like when you increase the temperature to 240, you see a little bit of growth. As you can see, the absorbance start to shift. but again, the surface is not active enough to grow uniformly. Only when you go to 310 degrees, the surface becomes very active, and when all the precursors added reaches the surface and the absorption start to shift, and you get a nice growth from 490 to 580 nanometer. And this is a recent example of the effect of addition rates. You can keep your temperature constant and you can change your addition rate. And in this case, for the indium arsenide, started with 8 mil per hour. So they were going really fast. What happens is your surface is active, but you are feeding so much precursor, so it all cannot go to the surface and react. So they start to nucleate separately in the solutions. And when they decrease the speed to 2 mil per hour, then start to see the nanoparticle growth with much better performance. So it is a fine balance between how fast you add, how fast your surface, how active your surface is, and how fast your precursor is converting into the monomers. So we have to find the right balance between all these three parameters to have a perfect and controlled growth. And this is a recent example of the seed method. And this paper is from Samsung. They used the seed mediated growth, which I developed in 2017 and 2018 to produce indium phosphide cores. And what they found was to grow the shell material, zinc selenide and zinc sulfide, you need to go really high temperature to have the core right in the middle of the cell. If you do at lower to even like 20 degrees lower, even at 320, you can have the core in the middle, but the cell is not completely covering the cores there. So that your core is exposed and you get very lower quantum yield. Only by going 340 degrees, and they managed to produce perfect spherical shell around indium phosphide quantum dots. And they achieved quantum efficiency of almost like near unity 100% quantum efficiency, and the full width half max of like 35 nanometer, which is quite excellent and which is very comparable to the best cadmium selenide quantum dots. So they managed to produce using these methods like indium green and red emitting indium phosphide with such high quantum yield and good color purity. So going into applications, you can, like they have quite few applications. So I'm going to focus on mostly optoelectronics. You can divide them into displays and sensors. In the displays, the quantum dots act in two different modes. One is photoluminescence, where you excite the dots with a blue light and they absorb and recombine and produce visible light. In electroluminescence mode, what you do is you inject charges, electron and holes into the quantum dots and they recombine and they produce lights. Whereas in the sensor, it is similar to the photoelectric effect. The light is absorbed by the quantum dots. You generate electron hole pair and you extract this electron hole pair to read the current and you produce sensing from that. And I should go into presentation mode for this, just to show like I have few animation there. Let me know if you don't say or can't say anything. So why do we need quantum dot displays? The first question comes to my mind is, do we really see real life colors in our TVs or smartphones? Now they are getting better and better, but still you don't see the real life colors. This is a picture of my daughter, which I took like a few years back. As you could see, the grass is not that green. Like when you see when you go to park and see the grass, it's so green. But when you see that in display, it just looks more like yellowish. And the dress she wears, like it was more bright orange color, but in here it looks more like dull and like. So what's the reason for this? Like most of the times our displays have like small color gamut. So what is the color gamut? It's the entire range of color that available on a particular device. So, and this triangle is all the colors visible to human eyes. This yellow triangle is the colors that can be produced by our normal HD TVs, and whatever colors is inside this yellow triangle only we can see. But as you can see, like the wide range of colors outside that yellow triangle. So how do we produce all these colors in our displays? All we have to do is like make more purer green and red and blue emissions, so you can push the triangle to the edge of the circle and you can get like wide colors. So how colors are produced in our TV? Like it's not like our TV has all the colors there. It's just only 3 colors. We have red, green, and blue. You just combine them in different ratios to produce all the colors in our TV. When you don't want any color, you just simply turn off that pixel and it looks black. When you mix all green, blue, red, and you get white light, and you just mix them in different ratios, you get all the other colors. What happens in our normal conventional TV is you have this blue light combined with phosphorus, it produces a white light. As you can see, like this green and red is not pure, they are just combined together and it's a very broad one. And it goes to the color filter that filters it, and you end up making 60 million colors, let's say. But if you can split that colors into 3 different purer colors, like pure blue, green, and red, you could end up making 1 billion colors. That's what the recent quantum dot TVs are doing. Like they produce purer green and red, and produce like billions and billions of colors in our TV. You can have purer, deeper red, green, and all the other colors. As a result, you would get with wider color gamut displays. Okay. So the quantum dot displays timeline, like as I said, like in 2013, Amazon introduced their Kindle with cadmium-based films, and it all changed when Samsung introduced their first TV in 2015 with cadmium-free quantum dots. As a matter of fact, like we worked with Samsung from 2008 to 2014, developing TVs or indium phosphide quantum dots. But what happened? They just cut us in the last minute and they produced their own TV and marketed. That's what all this IP infringement case and everything. Then we finally settled now with decent sum. And after Samsung introduced their TV and more display makers and computer companies such as HPR adopted this technology, and now you could see quantum dot TVs from Samsung, LG, HP, TCL, and Hisense, and now the lineup is keep growing. And also you could see like while it is continue to outperforming the organic LED TVs in performance and in number of unit it sells, like it is forecasted to outperform the OLED in the next 5 years or so. So how do we use the quantum dots in displays? So we have red and quantum dots and we put them in a resin and apply them a barrier film and make us a film. And this film goes into the normal LED TVs. You can have any LED TV, just replace the backlight unit with quantum dot films, and you get like much brighter and saturated colors. And you can simply integrate the existing LED. This is very cheap and it produces bright, pure colors. One of the drawback is the black color. The black you see from these TVs is not as good as the OLED, because here you have the backlight units continuously turned on, so you can't switch it off. Whereas in the OLED, you can switch off individual pixels, so you get like deeper blacks. But that is resolved in the second generation quantum dot displays, where you have organic OLED in the backlight, and you pixelate these quantum dots into subpixels. What happens is you turn on the blue OLED, the blue light comes through these green and red pixels and convert them into green and red purer light. And in this case, the quantum dot sits in the front of the display, and you get much brighter, purer colors and better viewing angle. You can see the TV almost like from 70-degree angles, still get the better pictures. Whereas with the LCD TV, you need to sit straight in front of the display to see. Whereas with this, you can sit in the sides at 70-degree angles. You could still see very clear pictures. And since it is based on blue OLED, you can turn them off individual pixels and you get brighter colors. And drawback is it is still very relatively new, and it would cost almost 4,000 pounds for a 77-inch display. That is almost like 4 lakh rupees for a 77-inch QD OLED display. And the future generation is based on electroluminescence, where like individual green, blue, and red quantum dots, they pixelated and they emit themselves by applying a charge. This would be very similar to the OLED and better performance than OLED, since the quantum dots have very high quantum efficiencies and better blacker color and thinner displays. You can even roll these displays, and yeah, it would just look like a paper. You can do most things with it. Quickly go on to one of the exciting new applications for these collider quantum dots is in the short wave infrared sensors. So what are short wave infrared sensors? SWIR sensor in short. It's an advanced technique used to produce image based on radiation in the region where SWIR spectrum, that is invisible to naked eye. So what we see, like when we use our cameras, it all have sensors to sense the light outside and capture it and turn that into a picture. Most of our cameras work only in the visible light. You all know, like when the light is not enough and when it is dark, you won't be able to see anything with our visible light based sensors. That's what all we have in our cameras now. So when you turn off the light and you don't see anything in the camera, you don't take anything. That's in the visible light. But when you go into near infrared and SWIR, these lights are not visible to human eyes. But you can use the sensors to take a picture, and that can produce quite good information and quite few information, especially like you can do nighttime photography. And water vapor, fog, and plastic and smoke, they all are transparent for the SWIR. So when you have a SWIR sensor in your phone or a camera, it can pass through the plastics, fog, and take a picture of the image. And also this can penetrate deeper into the skin, and it has better eye safety, and it can take very nice picture of our eyes. So it can be used in the security and biometrics. These are a few examples where the SWIR sensor can be used. As you can see the difference, the first one is the visible light, and you would say like it's just a normal person, he has a mustache and beard. But when you take a picture of the same person in a SWIR sensor, with a SWIR sensor, you could see clearly he is faking his identity, and his mustache and beard and these all are fake. Our normal human hair looks white in the SWIR sensor, but the synthetic materials, they look darker, and you could clearly see, okay, he is faking. So you could have this in the airports where people try to disguise in different, and they use face mask and like wigs to change their appearance. You could easily detect them using SWIR sensors. This has been used in armies and some high profile places, but not common in every places. And you could do the low light imaging. As I said, you could see this is a street. They have some street lights, but it is completely pitch black in the background and you don't see anything at all when you take a picture with visible light. But when you take a picture with SWIR sensors, you could clearly see the trees behind and the sky, and you could even see a parked car there. So yeah, it is very useful for even in the CCTVs. You could install them and turn off the light. You would still able to see something. Otherwise, in the normal our CCTVs, you need to have a bright light to see the human face or anything. But when you have a SWIR sensors, you could clearly see it in dark and it can take picture and videos. And another interesting application is in the food inspection. As you could see this apple, for the normal visible eye, it looks fine and it doesn't have anything. But when you take a picture with SWIR sensor, you could clearly see it is damaged inside the skin. So this is very good in the food industry when the packaging, like they can like take out the damaged goods. And also when you have these kind of features in our smartphones, what you could do is when you go shopping, like just open your camera and like quick check to the apple and say, oh, it's damaged, I don't need this, then just get a good quality rather than bring the apple home and just then you realize, oh, it's damaged. And so yeah, it's not too far to have these kind of facilities in our smartphones. It should be quite exciting. As I said, like SWIRs can pass through the plastics, and you can see this package, like it's just brown and you can't see what's inside. But when you take a picture with SWIR, you could clearly see the content inside. And yeah, as I said, like in this package, chocolate is missing. You could easily see, but normally you wouldn't be able to see. Also, fill levels, the fill level in any of the bottles. Some bottles, you would see like they're non-transparent. You need to shake them or weigh them to see how much it is. But SWIR sensors can pass through these plastics and you could see the fill levels and how much liquid you have in it. That's quite exciting as well. And most exciting of all is the seeing like to take pictures through fog and like cloudy conditions. Like as you can see this very foggy condition and you can't see anything with normal eye or like any cameras. But when you have SWIR cameras in a car, you could see through the fog clearly, and this could be huge in the automotive. And because many times we read like in China, like they had an incident, a foggy condition led to an accident and like 70, 80 cars collided each other and many people died. So when you have these kind of sensors in the car, you could clearly see through the fog and make your judgment, and it is quite advantageous. And you, as I said, like SWIR can take clear picture of eyes with fine details, where it can be used in the biometrics and to facial recognition and to unlock your phones with much better safety features. And coming to why quantum dots for SWIR sensing. There are SWIR sensors available. It's not like SWIR sensors are not at all available. SWIR sensors are there, but they are mostly based on indium gallium arsenide thin films. It is most mature but very expensive. It costs almost like $5,000 to $10,000 for a single sensor. So it is not available for everyone and everyone cannot buy this and use. So it's mostly used in military and space technologies. But whereas the quantum dots, they can absorb the same wavelength at relatively very low cost. You could make a sensor with $10. So you are decreasing the price from $5,000 to $10 for a quantum dot. So by doing this, you are enabling it to go into all the consumer electronics and you can reach wider population. Yeah, indium gallium arsenide, it absorbs from 1 micrometer to 1.7 micrometer. Whereas quantum dust, you can change their band gap quite easily by composition and size. They can absorb all the wavelength from 1 micrometer to 2.1 micrometer. And very low manufacturing cost, easily scalable. And yeah, it is very cheaper technology. And this just shows how the quantum dot sensor works. You have your silicon CMOS pixel layer already, it is mass produced. And you just fabricate your colloidal quantum dot film on top of it. And you fabricate your electrodes and you encapsulate. And when the light comes in contact with the SWIRE sensor, it excites the electrons, and you collect the electron and hole, and you read the electricity and produce images based on the SWIRE light. And yeah, what type of quantum dots are used for SWIRE sensor? The most commonly used is the lead sulfide, which can absorb from 700 to 2500 nanometer, which is quite mature, and you can produce like very mono dispersed particles of lead sulfide. But as again, with any material, lead is a heavy metal, it is quite toxic. So now people are moving away from lead SWIRE sensor to different materials. There are few lead-free alternatives available, such as indium arsenide and indium antimony. They all are 3-5 systems, and indium arsenide can absorb near IR SWIRE, and they have really good electron mobilities. And you can produce colloidally these materials. Whereas there is another material, indium antimony, which can absorb near IR SWIRE and mid-wave IR, and it is completely free of heavy metals. And so far, there are not established colloidal synthesis for this indium antimony, which is one of our focus here at Nanaco. And I'm leading a 2-year project, develop this indium antimony colloidal quantum dots for the sensor applications. And it's still a long way to go for this indium arsenide or indium antimony to be in the sensor. Because in the next year also, we will see SWIRE sensor in our phones and AR/VR glasses with lead sulfide. Maybe in a few years' time, they will be replaced with indium arsenide and indium antimony later. Yeah. Just to summarize the outlook, colloidal quantum dots, they have emerged over the past decade from just lab curiosities into multi-billion component market. It's one of the success stories of nanotechnologies, where bottom-up design, where you build the particles from molecules and which influence and affect the performance of macro-scale devices such as displays and sensors. Since the launch, quantum dot displays are dominating the market and delivering outstanding performance. And yeah, the sensors are very close to be adopted in consumer electronics. Synthesis of heavy metal free, such as indium phosphide and indium arsenide, have developed a lot in the last 5 years, and reaching near 100% quantum yield for the indium phosphide. And in terms of sensor materials, SWIRE sensor materials such as indium arsenide and indium antimony. Indium antimony is very early stage, and there is some development in indium arsenide, but still a long way to go, and lot of room for the research and innovation in synthesizing these indium arsenide and indium antimony materials for the sensors. And yeah, then it will open up a wide range of applications and so on. Yeah, that's it for me. Thank you so much for listening, giving me these opportunities. I'm open to any coping suggestions or ideas.
Thank you, sir. It was an excellent session. Now the session is open for discussion and clarification.
Afternoon, sir.
Hello?
Are you able to hear me, sir? Good afternoon, sir.
Yeah.
You're
Go
able to
ahead.
hear me, sir?
Yeah.
Yes, sir. How small is the particle that you have synthesized, sir? What is the minimum size of the nanomaterial that you have synthesized? And how do you account for its toxicity, cytotoxicity rather?
We don't do the toxicity analysis by ourselves. Like we rely on biologists to do the toxicity, and we just check the report and see which one is toxic and which is not toxic. And obviously, like like cadmium is toxic to human, same as the lead and mercury. These all are 2+, and they are very poisonous to humans and nature. So we just tend to avoid these materials. And yeah, for the indium phosphide and arsenide, we just go with the biologist. And in terms of the sizes, the smallest, I would say like 1.5 nanometers, the smallest crystal you can get. Below that, they exist as a clusters, not as a nanoparticles. So the smallest you could go is 1.5 nanometer in size. And then, yeah, the maximum you can go up to 10 or 12 nanometer in size for the indium arsenide. For indium phosphide, the size range from 1.5 to 3, and indium arsenide, it can go from 3 to 12 nanometer in size. Yeah, I guess that answered your question.
Thank you, sir. Thank you.
Participants, any questions?
Any questions, suggestions, ideas, all are welcome.
Sir, I think there is no more questions.
Okay, cool. Yeah.
Thank you, sir.
Thank you so much. Thank you for this opportunity. If anyone has anything, you can contact me on LinkedIn. Just Parthiban Ramaswamy. Then I'll be able to give some ideas, or you need some advice on projects or working in UK or any studying related. Yeah, feel free to contact me.
Thank you, sir. No duty is more urgent than that of returning thanks. To formally thank our resource person and to conclude the program, I invite the convener of this international seminar, Dr. D. Navanithan, sir, Assistant Professor, Department of Chemistry, JKK Nadaraja College of Arts and Science.
Thank you. Good afternoon, all. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. First of all, I would like to thank our eminent speakers, Dr. B. Saravanakumar, Junior Scientist, Central Institute of Petrochemicals Engineering and Technology, Bhubaneswar, and Dr. R. Parthiban, Senior Synthetic Material Chemist, Nanoco Technologies Limited, United Kingdom, for their countless insight in the field of energy harvesting and sensors. Our brain nerves are intensely stimulated by every word the speakers say, causing us to concentrate on the recent thirst for self-power energy and optoelectronic technologies. I would like to express my sincere gratitude to the Honorable Secretary Ma'am of the JKKN institution for her constant encouragement to host this online event. I also want to express my gratitude to the respected Managing Director of this institution for all his efforts to advance our knowledge with cutting-edge technologies. My sincere thanks to our beloved Dean Ma'am for her continuous directions and insightful suggestions to organize this seminar. And I want to express my deep regards to our Principal Ma'am for all of her help and support. I would like to thank our head of the department for her incredible support and guidance in planning this event. I am sincerely grateful to all our faculty members for their involvement and willingness to complete all the responsibilities beyond their comfort zone. I thank all the non-teaching members, student volunteers, for their endless support. Finally, I would like to take this opportunity to thank all the attendees who are actively involved and to make this event successful. Once again, thank you very much for everyone. Thank you.
Thank you, sir. Feedback link is shared in the YouTube and Gmail box, chat box. Kindly fill the same before 2:30 p.m. Soft copy of the certificate will reach you within a week. Now let's all stand for the national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलति तरंगा दव शुभ नामे जाहे दव शुभ आशीष माहे जाहे जव जय गादा जय गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Thank you all. Thank you all. The program is called off.